Hello, my name is Phoebe Andrews, and my topic is the Plum Pox virus, and my subtopic is its life cycle. It is important as a pathogen because it causes huge economic losses. It causes about $600 million in losses every year. It also affects every member of prunus, all stone fruit, and it is very hard to detect in some plants because in some plants it will not show symptoms for up to 3 years. An overview of this topic is that it is a single-strand linear RNA virus. It replicates in the cytoplasm of host plant cells. It is systemic. Its main symptoms are mottling of the leaves and fruit. It causes pinching and curling of the leaves. It can cause chlorosis and necrosis. It also causes hardening and mottling of fruit. It can cause them to be less sweet, and eventually it will reduce the fruit yield of a plant or eventually stop it completely. It will cause stunting from the detrimental health effects and very possible eventual death, which is why it is such a huge economic impact on the world's stone fruit crops. A detailed description of my project is that it is an illustrated children's book. I wanted to make it concise and fun. I started out thinking evil little boys, evil Keebler elves, and then I finally decided on Vikings because they pillage and plunder, and I thought, what better to describe a virus that is going around destroying plants. And here are my beginning sketches once I decided on the Vikings. This is the virus as the Viking. These are the symptoms and it becoming systemic. This is the method of transmission, aphids. And this is my final product in colored pencil. This is my finalized sketch of what I was going to work on. This is the final product. This is the illustrated children's book. This is the Plum Pox virus. Notice they do not have a pigment to their skin because viruses, unlike bacteria, will not stain like they do in a gram test. Their uniforms are mottled because that is one of the major identifier symptoms of the plum pox virus. These are the stone fruits, not all of them. This is a peach, this is a nectarine, this is a plum, and this is a cherry. This is a stone or pit, which is why the stone fruits are how the stone fruits get their name. These are the viruses, the aphids, which is the main method of transmission. When they pierce a plant, the viruses are taken up into the proboscis, remain viable in that aphid for a very short time, but when they are transferred into the new host plant when they pierce the tissues and the virus is transferred. Being a virus, it cannot infect a plant without a previous opening as a wound, which is why they need the aphids. This is the virus pounding in frustration on a leaf because it can't get in because it is a virus. This is the aphid piercing the leaf, the plant tissue, and transferring the virus via its proboscis with the infected sap that it's taken up. Transmission occurs other ways via human interaction, such as sharing between nurseries, grafting, and that's for long distances. Aphids are, of course, for short distances because the virus only remains viable in them for a short period of time, whereas if you're human and transferring actual plant tissue, it's going to remain viable longer. This is describing the systemic nature of the virus. It goes down to the roots, where we're calling this the Viking headquarters, the virus. And from there we can see this is an illustration that when a virus becomes systemic, it is able to go anywhere in that plant using the vascular system, thus the bus map. It can go to the fruit, to the leaves, to the stem, to the trunk, to the roots, anywhere it wants to go. The plum pox virus is able to infect any and all cells. It can infect leaf tissue, fruit tissue, all sorts of tissue. This is the virus replicating. You see them putting together another one of themselves in the cytoplasm of a host plant cell. That's why it's square. This is the space between the cells. This is the plant cell. This is the virus again. Because the symptoms do not appear for up to 3 years, or they can not appear for up to 3 years. This is not always true, but it is a problem, and it is hard to detect. That is one of the worries of the plum pox virus, is that it is hard to detect because not all plants that are infected show symptoms. These are those symptoms if and when they show them. The fruit and the leaves can become mottled. They can show chlorosis and necrosis. The leaves and the fruits can become malformed. They can become pinched and curled in. The fruits become hard and less sweet and malformed. And when these symptoms start showing, the fruit yield is decreased and can eventually possibly stop. The plant, because of its the virus's effects, the detrimental effects on the plant's health, causes stunting and possible eventual death. This is to show that in ratio, that the virus has taken over or is bigger than the plant now, which is why the plant is stunted in this picture. You can see the chlorosis and the malformation of the fruit and the wilting and chlorosis of the leaves. This is to show that the virus overwinters in already infected tissue and can continue to be transmitted and infect plants during aphids, which like to overwinter in plum trees, but it is not necessary for aphids to inhabit plum trees. This can go for any prunus. And they overwinter in infected plant tissues. And I hope you've enjoyed this presentation. This is my final product, the illustrated watercolor and ink children's book. This has been the plum pox virus and life cycle. Thank you.